Hi students, how are you? I hope that you are doing fine. In the last class we have discussed about the basic proportionality theorem. Today we will be doing the numericals of exercise 6.2. I have already uploaded many class 10 mathematics videos and the links are already given in the description. Please see it. If you are watching this video for the first time, please subscribe to it and share it amongst your friends. So let us start with exercise 6.2. Question number 1. In figure 6.17, 1 and 2, D is parallel to BC. Find EC in 1 and AD in 2. So in this question, we have to find out the value of EC. So according to the basic proportionality theorem, we know that since D is parallel to BC, we can apply the basic proportionality theorem. Therefore, AD by DB is equal to AE by EC. So, according to the basic proportionality theorem, AD by BD is equal to AE by EC. Therefore, AD is 1.5, that is already given, and BD is 3, that is also given, and AE is 1. We have to find out the value of EC. Therefore, EC is equal to 3 divided by 1.5, that is 2 centimeter. So, the answer is 2 centimeter. So, let us do question number 2. So, here also DE is parallel to BC, that is already given to us. So, we can apply the basic proportionality theorem. So, according to the basic proportionality theorem, AD by BD is equal to AE by EC. We have to find out the value of AD, that is AD divided by BD is 7.2, that is equal to AE is 1.8 divided by 5.4. Therefore, AD is equal to 1.8 divided by 5.4 into 7.2. So, 18 3s are 54, 24 3s are 72. So, the answer is 2.4 centimeter. Let us look question number 2. E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. The first question is P is equal to 3.9 centimeter, EQ is equal to 3 centimeter, PF is equal to 3.6 centimeter and FR is equal to 2.4 centimeter. We have to show that this is following basic proportionality theorem. If it follows basic proportionality theorem, then we can say that EF is parallel to QR. Now, let us see PE by ER. So, P is 3.9 divided by 3, that is 1.3. Now, let us see the other side, PF divided by FR, that is 3.6 divided by 2.4, that is equal to 1.5. So, the ratios are not equal. That means this divided by this is not equal to this divided by this. So, we can say that this line EF is not parallel to QR. Now, let us do the second question. So, here P is 4, EQ is 4.5, PF is 8 and FR is 9. So, let us see the ratios. PE by EQ, that is 4 by 4.5, that is 8 divided by 9. Let us see the right hand side. PF divided by FR is equal to 8 by 9. So, these ratios are equal. Therefore, EF is parallel to QR. Now, let us do question number 3. Here EP is 1.8, PQ the total distance is 1.28, PR is 0.36 and the total distance is 2.56. Now, let us see the ratios. EP divided by PQ, that is 0.18 divided by 1.28, that is equal to 9 by 64. Now, let us do the other side. PR divided by FR, that is equal to 0.36 divided by 2.56. So here 9 again and again 64. So the ratio is 9 by 64 on both sides. That means EF is parallel to QR. Now let us look question number 3. In the following figure, if LM parallel to CB and LN parallel to CD, prove that AM by AB is equal to AN by AD. Now let us do this question. What is given to us is LM is parallel to CB and LN is parallel to CD. Now you see there is a triangle ABC, they are proportion, the bigger triangle. Now in triangle ABC, what is given to us, LM is parallel to CB. If LN is parallel to CB, we can apply the basic proportionality theorem. Therefore, according to basic proportionality theorem, we can say that AM divided by AB, that is AM divided by AB is equal to AL divided by AC. AL divided by AC. Let it be equation number 1. Now consider this triangle ADC. So in triangle ADC, it is already given that LN is parallel to CD. So we can apply the basic proportionality theorem. Therefore, according to the basic proportionality theorem, AN divided by AD is equal to AL divided by AC. This divided by AD is equal to AL divided by AC. Now let it be equation number 2. Now you see equation number 1 and equation number 2. The right hand side, that is AL by AC, is there on the right hand side. If right hand side are equal, then left hand side will also be equal. Therefore we can write AM by AB is equal to AN by AD. This is what we have to prove. Now let us do question number 4. In figure 6.19, DE is parallel to AC, DF is parallel to AE. Prove that BF by FE is equal to BE by EC. Now what is given to us is DF is parallel to AE and DE is parallel to AC. Now let me divide this figure into two figures. Now this figure ABC, I have taken only this portion. Now we can say that DE is parallel to AC, and the second figure is AE is parallel to DF. So I have divided this figure into two basically for your understanding. Now in this triangle, since DE is parallel to AC, which is already given to us, we can say that we can apply the basic proportionality theorem. That means BD divided by DA is equal to BE divided by EC. Let it be equation number 1. Now from this triangle, that is triangle BAE, we can again apply, because DF is parallel to AE. So we can apply the basic proportionality theorem. So according to BPT, BD divided by DA is equal to BF divided by FE. Let it be equation number 2. Now you see, in the left hand side is same. Here also BD by DA, here also BD by DA. Therefore, the right hand side will be equal. That means BE by EC is equal to BF divided by FE. This is what we have to prove. Now let us do question number 5. In the following figure, D is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Now let us understand the meaning of this question. What all things are given to us? ED is parallel to QO and DF is parallel to OR. This is given to us. What we have to prove is EF is parallel to QR. This is what we have to prove. Now consider this triangle POQ. So in this triangle POQ, POQ, we can ED is parallel to Q, that is already given to us. So we can apply the basic proportionality theorem. That means PE divided by EQ is equal to PD divided by DO. Let it be equation number 1. Now consider this triangle, that is POR. So in triangle POR, again DF is parallel to OR. So we can apply the basic proportionality theorem. Therefore, PF divided by FR is equal to PD divided by DO. Let it be equation number 2. Now you see the right hand side, both are equal. If right hand side are equal, then the LHS will also be equal. So we can write PE by EQ is equal to PF by FR. So we have proved that PE by EQ is equal to PF by FR. That means this divided by this is equal to this divided by this. That means EF is parallel to QR. EF is parallel to QR. This is what we have to prove. So let us do question number 6. In the following figure, A, B and C are points on OP, OQ and OR respectively such that AB is parallel to PQ and AC is parallel to PR. Show that PC is parallel to QR. Now look at this figure. What is given to us? AB is parallel to PQ, AC is parallel to PR. We have to prove BC is parallel to QR. This is what we have to prove. Now, first of all, consider this triangle, that is POQ, this triangle. What is given to us is AB is parallel to PQ. So we can apply the basic proportionality theorem. So in triangle POQ, this triangle, since AB is parallel to PQ, we can say that OA by AP is equal to OB by BQ. Let it be equation number 1. This divided by this is equal to this by this, because AB is parallel to PQ. Now consider this triangle POR. So in triangle POR, what is given to us? AC is parallel to PR, AC is parallel to PR. Therefore we can write OA by AP is equal to OA by AP is equal to OC by CR. Now let it be equation number 2. Now look at equation number 1 and equation number 2. This is OA by AP is there on the left hand side. That means the right hand side will also be equal. So OB by BQ is equal to OC by CR. When is it possible? According to the converse of basic proportionality theorem, we can say that BC is parallel to QR because OB by BQ is equal to OC by CR. So this is possible only when BC is parallel to QR according to converse of basic proportionality theorem. Now let us do question number 9. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO by BO is equal to CO by DO. This question is very important as far as your exam is concerned. Now let us understand the meaning of this question. What is given to us? It is given that AB is parallel to DC. This is given to us. And the diagonals intersect at the point O. First of all, let us draw EF through O such that this EF is parallel to DC. So this is parallel to this. Now consider this triangle, triangle ADC. So in triangle ADC, EO is parallel to DC. EO is parallel to DC because we have drawn a line EF such that this line is parallel to DC. Then we can apply the basic proportionality theorem. That means AE by ED is equal to AO by OC. Let it be equation number 1. Now consider triangle ABD. ABD. Here you can see that AB is parallel to EO. So EO is parallel to AB. Then we can apply the basic proportionality theorem. That means AE by ED, that is this distance by this distance, is equal to BO by OD. Let it be equation number 2. Now you see equation 1 and 2, the left hand side is equal. If left hand side are equal, we can say that AO by OC is equal to BO by OD. Now look at here and here. We have to prove this. So, and look at here. Now if you rearrange it, if you take this BO here and OC there, that is AO by BO is equal to OC by OD. So this is what we have to prove. Now let us do question number 10. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO, so that ABCD is a trapezium. Now let us understand the question. We have just done the other way around. Now we have to prove that ABCD is a trapezium, and the condition given to us is AO by BO is equal to CO by DO. In the previous case we had to prove this. Now we are given this and we have to prove that this is a trapezium. That means AB is parallel to DC. This is what we have to prove. First of all, let us draw a line EO parallel to AB and consider this triangle ABD. The last case also we have considered this triangle. So ABD, in triangle ABD, since this is parallel to this, we can apply the basic proportionality theorem. That means AE by ED is equal to BO by OD. Let it be equation number 1. Now what is given to us? AO by BO is equal to CO by DO. Let us rearrange it. We can rewrite this as AO by CO. We are taking this down. So AO by CO is equal to BO by DO. We have just rearranged it. I have taken this CO here and this BO there. Now look at equation number 1 and equation number 2. You can see that BO by OD and BO by DO or OD, this is same. Both are same. That means the LHS will be same. That is AE by ED is equal to AO by CO. Now what is the meaning of this? That is AE by ED. AE by ED is equal to AO by OC. That means this EO is parallel to this line according to the converse of basic proportionality theorem. That means ED is EO. EO is parallel to DC. We are showing that EO is parallel to DC. That means AB is parallel to EO is parallel to DC. AB is parallel to EO is again parallel to DC. That means AB is parallel to DC. That means AB is parallel to DC. When is it possible? That means it is a trapezium. With this we have come to the end of exercise 6.2. I hope that these questions are very clear to you. I have uploaded many class 10 mathematics videos Please see it and share it amongst your friends. If you have any doubt, please ask your queries in the comment section. Thank you.